that period of time. So without any more further ado, let me turn it over to Joan. Thank you, Joan.
Thank you very much for that introduction. And Barbara, I want to remind you to start the recording.
I forgot to remind you.
So, wow, crazy times, huh, everyone? But I can think of nothing better to do than talk about our beautiful Earth and to think of ways that we can be part of the solution instead of the part of the problem. So with that, we decided to continue with our discussion tonight. So this is recent evidence linking old growth forests with carbon uptake. And by recent, I really mean in the last 10 or 20 years. And let's jump right into that. First of all, I wanted to let you know, if you're not familiar with the Zoom, that if my face or other faces are in your way, that at the top of that bar that have the faces, there's different views. You can try clicking on different views, and you can also try to click and drag that bar out of the way if it's getting in the way of a slide you're trying to read. So this first slide, humans have reduced global forest cover from 46% to 31%. This is one of the saddest facts that we have to face, and that this forest reduction continues. And most of this is through commodification, you know, creating products that we want to sell. This isn't people clearing for subsistence growing. This is big business doing a lot of this. And so if we look at this chart, we see those blue dots going down from 1650 on the left to past 1950 on the right. Well, that's the same data, but that's just shown in graphic form. That's the forest loss over the last few hundred years. And you can see that the forest loss has slowed somewhat. Early on, we were doing a really fast job of clearing those forests, and it has slowed, but it has not stopped, which is an incredible fact to me. We know how important the forests are. We're always talking about planting new forests, but guess what? We haven't stopped even destroying the forest yet. Then the other line on this graph, the green one, is the atmospheric carbon dioxide levels. And those levels are shown on the right. And what we can see is that as the forests have declined, the carbon dioxide levels have gone up. Now, those levels are not going up just because we're losing forests. They're primarily going up because of our fossil fuel burning, which really didn't start until after the 1800s. You can see that going up, but the fact is that both things are happening at once. We're burning fossil fuels and we're reducing the forests. So no surprise that the carbon dioxide levels are going up in the atmosphere. So the fossil fuel are contributing more to this increase in carbon dioxide, the fossil fuel burning, than the forest removal. But still, the forest removal counts for about a third of this carbon dioxide increase. And I'm sure 90% of the people listening tonight know about the formulas down in the bottom right about photosynthesis and combustion, but just a reminder that the carbon dioxide is taken into the plant by the process of photosynthesis and changed into plant tissue, so wood and sugars. And then combustion down the bottom is you take these carbon-containing molecules and you burn them, and that releases carbon dioxide.
Lisa Gezi, join the meeting.
Combustion can either be slow, it can either be fast, excuse me, as in burning fossil fuels, or it can be slow, as in rotting of leaves and branches on the forest floor. That will also release carbon dioxide. Okay. So how does the carbon get into the plants, into the trees? Well, it enters the trees through the leaves, and this is an enlargement of the pores on the leaves that are called stomata. And these stomata, they make the world go round. You know, if we could really see them closely, we would appreciate them so greatly. They're like little mouths, and they're always opening and closing. And actually 40% of atmospheric carbon and over half the water circulating in the atmosphere move through stomata each year. So we need to really appreciate these stomata. And that so much of the carbon is going through them. Yes, some ends up being released, and some, you know, goes down into the soil, but still, this is how the carbon is taken out of the atmosphere by the trees. And then once it's taken in through the leaves, where does it go? Well, you can see very little of it stays in the leaves. Only 1% of the carbon goes into the leaves. The majority of it goes into, see there, the trunks and branches. So when you see that brown, you are seeing, it's almost like solidified carbon dioxide, that carbon dioxide that's stored in those big molecules in the wood, these molecules like cellulose. And then a lot of the carbon also goes down into the roots, where it can become part of the tree roots. We see there 13%. Or look at that bottom right where it says soil organic matter, 45%. That's more than even the trunks and the branches. This carbon is going down into the soil. Now, what happens to it there? We are still learning about this. We are learning so much about how these tree roots are intertwined with the fungi in the mycorrhizae, and that a lot of that carbon from the atmosphere gets converted to sugars that then goes down into the tree roots and then into the fungal mycorrhizae and into the soil. So the carbon doesn't all stay in the trees. It gets spread out in the soil and the mycorrhizae. It's shared with other trees. And it also, this is something, I'm a biologist, and this is an area that we really need to learn more about, because that the tree roots and the soil organic matter, that's a whole ecosystem under there of all sorts of things, not just fungi, not just tree roots, but little mites and paramecium and algae and all kinds of organisms, beetles, and it's a whole food system under there. And that carbon is circulating under there. So if we cut that tree and expose that soil, a lot of those things are going to die, and they're going to release their carbon back into the atmosphere as they burn, slow burn by rotting. So trees, excuse me, I have to kind of move around this so I could read my slides. Trees accumulate carbon as long as they live. This was a paper done in 2019. Amazing that before that, we didn't realize this. We thought trees grew and they got big, and that was it. At a certain point, they kind of break off branches while other branches go, and they reach a steady state. That's what we used to believe. But now we know that they continue to accumulate carbon as long as they live, and that a single big tree can add the same amount of carbon to the forest, the solidified carbon, within a year as contained in an entire mid-sized tree. Now I'm going to word that in another way. So you have a big old tree, and it's adding a lot of solid carbon, but most of it is in the branches and maybe a thin ring in the trunk. So when you look at that tree, you think, oh, it really hasn't grown much this year, but you see this small tree in your front yard that's a third bigger, and you think, oh, that small tree's growing a lot faster. But really, if you could measure the carbon, you would see that that big old tree put on as much carbon as the mid-sized tree in your yard. And that mid-sized tree might have taken 40 years to grow. So the big old tree can put on that much carbon in a year that took a smaller tree many, many years. And so that tree accumulation increases with tree size. And this graph here is, it was put together by Bob Leverett, who is still trying to answer these questions to show how much carbon actually is contained within a tree as it grows. And this particular graph has not even been published yet. So the old think was that old growth forests are carbon neutral. The trees grow, they store carbon, but they die and rot away. And it's kind of a steady state. That's the old think. The old think was that, you know, we clear a forest and there's new trees coming up, and that's where the sponges are for carbon. That's the old think. But the new findings are
Lisa Gezzi joined the meeting.
Old growth forests continually accumulate carbon both above ground and below ground. So they're not a steady state, these old forests. They're continually accumulating. And you can see that was a paper published in Science. And a lot of that carbon is going into the ground. We don't really understand that. How much carbon can that soil hold? We're still trying to figure that out and research that. This forest carbon index shows how the carbon in a forest increases with the age of the forest. So earlier I was talking about the age of a tree and how carbon increases with the age and size of a tree, but this is in a whole forest. And you can see there that the older the forest gets, the more carbon that forest holds. So this has led to another paper, recent paper about proforestation. I don't know how many of you have heard of this term proforestation. It's pretty new. And the idea is that if we just let the forests get older, they are naturally going to accumulate more carbon and they'll be more efficient at taking carbon out of the atmosphere. That's all we have to do. We don't have to plant more. We don't have to do anything fancy. We just let the forests get older and they will remove carbon from the atmosphere. The other things we're just learning is that trees can share this carbon that they put into the soil and their roots, and that this soil carbon network through the mycorrhizae gets more complex as a forest ages. This information is so new. It's so interesting to me that now most people have heard this. They've heard the work of Suzanne Simard. They know about this World Wide Web of mycorrhizae in the trees sharing resources. But 20 years ago, we had no idea. So what are we going to learn in the next 20 years and the 20 years after that? We need to keep some of these intact forests to learn from them. And she had to go to these old forests to study mycorrhizal networks. And that those circles on the right are from a paper from her lab. And the circles represent Douglas fir trees, and the darker and larger the circle, the older the tree. So if you had time to really study this diagram, you would find out that the oldest trees were connected to the most other trees and were connected by multiple fungal networks. So this isn't just one species of fungi that's connecting them. This is multiple fungi. So I believe the oldest tree in this study was connected to 47 different trees by 11 different strains of fungi. So if you cut down that one tree and didn't have any idea what was going on underground, you would think you really weren't making that much of a difference to the forest. Or you might think, oh, we're giving the other trees more light. But in fact, you are disrupting a whole network in a way. And we don't understand that disruption yet. So we have to be a little humble and realize we don't know everything. And as these networks become more connected, they take up more carbon. And that's one of the reasons that old growth forests take up more carbon into the soil. Another thing, this is a paper from 2018, and this is about the global importance of large diameter trees. This photograph was taken in Philadelphia, almost right in the heart of the city. And this is one of the forests in the old growth forest network. And that's a big old beech tree. And why does it have those ripples on it? I don't know. I think I took that photo or had someone take the photo, and I've shared it with some people, but haven't gotten a great answer yet. But one thing you do notice, this is a little off the side, but as these trees get older and older, they become more individuals, just like us. So we need to appreciate that. Back to the paper now. The largest 1% of trees in a forest equaled over 50% of the total carbon containing biomass. So think back to that slide where I was talking about the carbon in an entire forest. Well, 50% of that is going to be in 1% of the trees, and those are the biggest trees. So we can't have a forest that's storing a large amount of carbon without allowing for the large trees. So if you have a forest full of small trees, they might be growing quickly, but they're not going to contain that much carbon. And this is a very sad fact that the large old trees are declining worldwide. And they are declining for many reasons. We could list a lot of them. The land clearing, a lot of times has happened in the places with the largest old trees. I mean, even think of our nation here. When the Europeans first came, we had vast old growth forests. And they looked at those forests with the largest trees and said, oh, that must be the richest soil. And that's where we want to clear to grow our crops. And so many of our forests with the largest old trees were cleared for that reason. And the same thing is still happening in the tropical areas. And it is still happening. This photograph was taken just a few months ago in Maryland. And it's a beautiful old forest, an old growth forest, but it's privately owned and it's marked for cutting. And when I hiked through this forest, every single large tree was marked to be taken down. These are tulip poplar trees. So this is not something that happened somewhere else or something that happened long ago. This is still happening right now. And if you're curious, you might be, I'll just share that. So we're trying to save this forest, and we offered to buy out the timber contract and pay the owner for the amount of money they would have gotten for the tree. But the 92-year-old owner has refused that. And right now, there's nothing to stop the logging that we can see, unless there's some divine intervention and he comes to his senses. But there's no laws against this happening. There's no protection for the large old trees. And of course, you know, what's going to happen? Those trees will come down and that carbon will go into the atmosphere. And these trees, by the way, would probably be used just to make caskets And the other big beech trees in this forest would be used to make like fancy construction platforms for cranes. They call them mats, things for construction equipment to ride over. So this is where what's happening to our large trees. So this graph shows carbon accumulation in a forest depending on how that forest is managed. So the red line with the arrow pointing to it shows a forest that is unmanaged, so just left alone. And the unmanaged northern hardwood forest will sequester more carbon than any of the active management. So the active management is shown by all those other dotted lines like shelter wood cuttings and clear cut. Those management tendencies, yes, the forest will start to recover its carbon, but then the carbon will be taken away again and some of it released when it's cut. So if people tell you that forests need to be managed for the best carbon uptake, this is not true. This is a myth. The best carbon uptake is in a forest that's left alone. And there's the scientific paper if you need the reference. A little bit more about carbon in the forests. And this is the carbon debt created by industrial forestry, we'll say, or any type of frequent management. So on the left, in a native old growth forest, and this is in Oregon, in an old growth forest, we might find 323 tons of carbon per acre in that forest. But if you've ever been out west and you've seen those vast acreages of industrial forest management, these are the Weyerhaeusers and that type, you see that the trees are much younger, and those forests contain about 113 tons of carbon per acre. So if we could somehow let more of those forests go back to the old growth state, we would be taking more carbon out of the atmosphere because that carbon has been released into the atmosphere. This is the proforestation I mentioned earlier. Now, people that get uncomfortable when you talk about not logging say, well, the trees are going to die anyway, and other things can take a forest out. And that is very true. If a forest is attacked by insects like the pine bark beetles, and a lot of those trees die, that can affect the carbon contained in that forest. And some of those trees are going to fall over and rot. There can be big windstorms that will kill trees and release carbon into the atmosphere. There can be the fires like we saw this summer that are releasing carbon into the atmosphere. But when you look at each of these different causations of carbon going into the atmosphere from the forest, the number one is forest harvesting. And this accounts for 85% of the carbon lost from forests each year. And a lot of that loss is from the smaller parts of the trees that are left on the ground, and those are going to rot very quickly. And it's also because of that soil ecosystem I talked about and that soil carbon that gets released back into the atmosphere. Now, what about the actual logs that are taken out? Well, that's a little bit more complex, and it really depends on what those logs are used for and how they're treated, how long that carbon can stay embodied. So if that wood is turned into pellets or burned in a wood stove, then that carbon dioxide is going to go back into the atmosphere very quickly. Or if it's used for something like pallets, that will go into the landfill, and that will then release carbon and other gases. But if that wood is turned into a fine piece of furniture that might be around for 100 years, then that carbon can be embodied for a longer time, but it still doesn't balance out. Still the forest harvesting, because of all the other parts of the tree and all the other ecological reasons, ends up in a net release of carbon dioxide to the atmosphere. So that's what I wanted to say about carbon. And then I'm going to pause here maybe for a few questions, and then I'm going to talk about the Old Growth Forest Network, which is the organization that I formed to do something about this. But before we get into the questions, I just wanted to mention that carbon is one thing, and it's very important, and it's the topic of our conversation today. But for me personally, biodiversity is even more important, because this is the beauty and the evolution and the parts of our earth. And the forests contain so much of that biodiversity. 80% of the terrestrial biodiversity is contained in forests. So when we lose those forests, as I showed in my first two graphs, we're not just losing something that's taking up carbon dioxide, we're also losing precious biodiversity on the planet. So that's another important reason to protect forests. So Barbara, should we take a couple questions now?
Yes, we've got quite a few, or a good number in the chat if you're ready. The first one is, how would you propose to use these scientific findings to protect land and to preserve mature and older forests?
Well, I will be getting into that in the next part about the Old Growth Forest Network, but I would also say that one way we can use these findings is if we really want to reduce carbon dioxide in the atmosphere and recognize the role that the forests play, that people need to be rewarded financially for their part in their forests removing carbon from the atmosphere. So people are paid for the wood fiber that comes out of their forest. I think they should also be paid for the carbon that those forests are taking out of the atmosphere, and this will get them to keep it. And that is happening. There are big carbon markets in that now, and it will help. I want to also address another question that someone sent in earlier, and that was about the question was something like, should 30% of the national forest be set aside for preserves to help with this carbon balance and the biodiversity? You know, there's the big 30 by 30, you know, save 30% of the land. And I feel absolutely that our national forests can be a big part of the solution here. And we could start with 30%, but we may even want to consider all of our national forests being these places of proforestation, places of carbon sequestration, places of biodiversity. And that doesn't mean that I don't believe in any harvesting of forests, because there will still be harvesting from the private forests. So really, if you look at it, why should the private forest owners who have to buy their land and have to pay taxes be competing with the national forests for the timber markets? You know, the national forests, nobody's paid for them, nobody's paid taxes from them. So it would actually help the private forest owners get a greater price for their wood fiber if they weren't competing with the national forest. And if those prices were higher, we would respect that wood more and not waste it so much. So thank you for that question, who asked that.
Patricia asks, when I start to plant trees this year, should I think about which species I plant near existing trees? Do certain trees communicate better with each other than others?
Wow, that's an interesting question, but I would just say that it really doesn't matter as long as they like the same type of soil. So certain trees like to be dry. So if you have a dry area, you want to plant those and plant those together. And certain trees like to be in wetter areas. So those should be planted together. And I'll just mention that when I visit these old growth forests, one of the signs to me that I'm in an old growth forest is that I see big trees of many different species very close together. So when you talk to someone who studied only textbook knowledge of these forests, they somehow think that these trees are competing and that they're going to hurt each other. But when I go to the forest and I see them, many of them are doing just fine, pretty close to each other.
Okay, next question. Julie asks, what are options to wood used for paper? Can we cultivate more bamboo or other plants?
Yes, well, people have talked about hemp, bamboo, paper, but I believe that recycling, that the wood fiber that we do use for the paper is the best. And for the Old Growth Forest Network, which I'm going to launch into now, we always use 100% post-consumer recycled paper. And again, you know, if our scrap paper or old paper was more valuable and people actually could get paid for it, then there would not be so much of it going into the waste stream. So at this point, I'd like to talk a little bit about what we're trying to do for the forests, if that's okay. And then I'll take more questions at the end.
Okay.
I'm going to focus on Virginia for a bit, just a little history. You know, when the early Europeans were here, what they found was wasn't a state yet, but the land that we now call a state was 80 to 90% forested. And really the only places that weren't forested were the wetlands and some of the peaks and the rocky areas. And that we soon got busy clearing those forests, immediately shipping timber back to the old world and just clearing it out for agriculture. By 1930, the forest cover was the lowest. Then it started increasing as people abandoned some of these agricultural fields that were not too productive, or as people went back to the cities, or as people could not afford to pay taxes on the land, trees came back in. But since 1980, forest cover has been declining again and declining every year. So what can we do? You know, it's not just what are the problems, what can we do to reverse this destruction that's happened and improve the planet? This is the question I asked myself. And not just for myself, but for the next generation, right? We need, when we look at these solutions, we need to think into the future, because we can preserve all the forests we want, but if we don't have a next generation that's going to preserving those forests after us, all our efforts will be in vain. So how are we going to get the next generation to want to preserve those forests? And the answer is they have to learn to love them, right? They have to experience them, enjoy them, love them, so they will want to protect them. So that's part of the solution. How will these young people learn to love these forests if they don't get out into them? How will they get out into them if they're all so far away? These were the thoughts that were coming to me as I was working on my second book, Among the Ancients, where I visited one old growth forest in each of the eastern US states, the 26 eastern US states. And I realized that if we could just preserve one forest in each county of the US, that no child would be too far from one of these preserved forests that they could go to at any time, open to the public forest, accessible forest that would never be logged again. That's all, just one forest in each county. And I went home after this idea struck me on the road, and I Googled counties in the US, and this is the image that came up. And I knew, oh boy, I have my work cut out for me. Not every one of these counties can support forest growth, but at least 2/3 of them can. So that became the mission of the Old Growth Forest Network. One forest in each county protected from logging and open to the public. And we started this in 2012, and we now have 116 forests in 24 different states in the Old Growth Forest Network that anyone can visit at any time. And you can find out about where these 116 forests are and exactly how to get there by visiting our website that Cliff shared, oldgrowthforest.net. And there you can also link up and become part of the network that I'm going to explain to you. And you can also donate there if you want. So I hope you will get a chance to visit that website. So how do we do our work? Well, here's Virginia, 95 counties in Virginia. That's a lot of work, right? Mm-hmm. Very small organization. For a couple of years, I was the only employee. I was part-time first, then I went to full-time. And now we're fortunate that we have a small handful of amazing women working with us to do this, but it's still a lot of work. It's still, with that small group, we can't do it all. So what we need to do is try to find someone on the ground in each of these counties that can help us. And we call them our county coordinators. And Virginia has been amazing. One of the first states that really embraced the concept of the Old Growth Forest Network. And people have signed up. In blue there, it shows the counties where we have county coordinators. And in the yellow, where we don't yet have county coordinators. Now, you don't have to live in the county where you're county coordinator. So if anyone's looking at this and they say, oh, you know, I know of a forest in, let's say, Buckingham County, please sign up to be a county coordinator, and we will let you know what that involves and before you decide for sure if you want to take that on or not. Help us find the next forest for the Old Growth Forest Network. So here is a map of what we've accomplished in Virginia so far. Let's look at the yellow first. So a yellow is where a forest has been nominated in that county. Wow. And anyone's also welcome to nominate a forest to us, and we keep a list of these nominations. Virginia has more forests nominated than any other state. And the reason is because early on I gave a talk and some folks from VCR were there. Is it VCR or VCCR? VCR, Virginia, VCR were there. And they said, we can help you. And it took them 6 months in their spare time, but they nominated many forests, 95 minus 24, what's that math real quick, in the state. And they said that even they were surprised to learn that in 24 counties, they could not find a single forest that was protected from logging and open to the public. So that shows us the work that needs to be done. So we have nominations, and we have also completed dedications. That's what we call it when we've picked the best forest and we make sure it's preserved and we have a celebration. And those dedicated forests are shown on the right there. And as I said, you can visit our website and find exact directions to any one of those forests. Now, not all of these are old growth forests because not all counties have old growth forest left. So sometimes there's old growth forests, but other times we pick the oldest forests that we can find and say, okay, it won't be cut again. It's going to be old growth in the future. So that's our goal. Now, what about your fair county? This is the exciting part. I'm moving my screen. What about Rockbridge County? Well, we have one nomination there, and that was the nomination that was done by VCR. And that doesn't mean that this is the only one or the best one. So we're counting on you to nominate some forests in your county. And we also need a county coordinator. How fun is this? So the county coordinator then will get all the nominations and we'll share with them what's been nominated. And then they need to go out, hike around, and they are looking for a forest that's open to the public, relatively accessible, protected from logging, and as old as possible. And then once they identify and say, this is the best one out of all these 4 or 5 that were nominated, then we approach the forest managers and let them know, and then start the process for a dedication. And this photo here was a dedication from this year. And this was Voorhees Nature Preserve. And it was, that one is owned by the Nature Conservancy. So these forests can be under any ownership as long as they're open to the public. So federal, such as Montebello Slopes, or state or organization or university, there's land trust. It can be owned by any entity as long as it's protected and open to the public and accessible. Okay. But in addition to building the network, we also speak out for forests that often are called protected, but they're not really protected, such as this forest I'm sitting in there, which is a true old growth forest in Maryland, and that's in a Maryland state park. And if you looked at a map, it would say that that's protected, but there's really no laws protecting that forest from being cut. So we could have a future governor that could decide to cut that forest because they wanted the money. The bottom right, one of my students standing on a white oak stump in a state forest, right? So a lot of the state forests, again, if you look at the maps, it'll say, oh, protected, not really protected. The same with a lot of the land trust lands. You know, look, oh, owned by a land trust, it must be protected, or with an easement on it from a land trust. But a lot of those easements do allow logging, and those forests can be clear cut. So we're trying to really protect forests, just not in name. And we are trying to partner and collaborate with groups to save forests nationwide. So we do get calls from people, help me save a forest. And we're collecting ideas for how to do that and advising people. And in Virginia, 87% of the forests are privately owned. So what private landowners do is so important. And often the private landowners don't understand about forest management. They think it needs to be managed, so they'll call up a forester to come and look at their forest, and guess what they're going to be told in many cases? You know, that they want to get some value out of the trees, they're just going to die, you know, that the forest needs to be managed. We try to educate them that this is not always the case. And for those special people that have forests, that own forests, family forests, that have made the commitment not to log their forest, whether it's by easement or just by handshake, we call the private forest network. And we welcome people into that. You can also nominate your own forest if you've made that commitment on our website and become part of the private forest network. And we send you a sign. And those forests are not open to the public. So we welcome communication from private forest owners trying to save their forests. So wrapping up then, this is a big job to save these forests. And we need to work together. We need to retain the older native forests. We need to be not just a network of forests, but a network of people. And so I'm so glad to meet you tonight so that you can be part of this network of people who care about forests, and we can work together and stand together for the forest. This is a dedication in Ohio, by the way. So connect with us, I'll connect with you, and we'll save these forests for biodiversity, for the atmosphere, for beauty. Thank you.
Thank you, Joan.
I do have a couple of more questions in the chat. Are you up for a few more, Joan?
Sure.
Okay. Leah asks, can you talk about how tough it is to regrow new forests after old forests are cut, and address the soil that is depleted and not like it was when the original trees grew there 100 or 300 years ago? And also address our new climate change challenge of droughts, heat, and floods. That's pretty broad.
Yeah, so, and by the way, I can see the chat now, so I'll just address a few that stand out to me. Thank you. So once you clear a forest, it is very difficult and could be impossible, we don't really know at this point, to bring it back to the way it was. And part of the reason for that is the climate change. You know, a mature tree can kind of hang on if there's a drought or it gets colder or hotter, but the same young trees can't always survive that. But really the largest change is with the invasive species. And I've seen this really in my own lifetime. So you have people that were in the forest industry 50 years ago thinking, oh, you can cut that forest and it'll recover. But things have changed in the last 50 years with invasive species. So now when you cut a forest, you're letting sunlight in, and invasive species show up literally out of nowhere, and they can interfere with a new forest recovering. So it's very difficult. And we're also losing the mycorrhizae. The fungi die when the soil dries out. I will also like to address property owners. Should we not try to clear out fallen, damaged trees, but rather just let them stay put? Yes. There's actually more life in a dead tree on the ground than there is in the standing trees. A very important part of the biodiversity, those dead trees. And this is covered in my book, Nature's Temples. And let's see. Okay. How long does it take for a forest to reach old growth status? Well, it really depends on the type of forest, right? A redwood forest might take over 1,000 years to reach old growth status, but in the East where we are, I would say after about 150 years, you have trees, a lot of them reaching their maximum lifespan, starting to fall and die of old age, younger trees coming up. And so that would be where you're kind of turning the corner, and I'll call that an old growth forest. But really it might take another 100 years past that for all the biodiversity to recover too, and for the soil carbon to build up. Do we partner with the Nature Conservancy? A number of Nature Conservancy forests are in the old growth forest network, but it's very interesting. The Nature Conservancy forests aren't really protected. They can do with them what they want. A lot of them, most of them. They can sell them if they want, they can log them if they want, and they have logged a number of their forests. So if we work with the Nature Conservancy, we have to get them to sign a memorandum of agreement saying that this forest will be protected. And I have to tell you, there is resistance with some Nature Conservancy forests that they want to keep their management options open. And what we're trying to do is actually not keep those management options open. So we understand that, again, not every forest has to be left alone. We're just looking for one in each county, please, at least. So I will, 500-Year Forest Foundation. Yes, I'm familiar with them, and you are very lucky in Virginia to have that great organization. No other state has anything like that, and they don't work beyond Virginia yet. And what 500-Year Forest Foundation does, if you're not familiar with it, this was also started by somebody just like myself that said, we can't lose these last of our older forests. We need to protect them. So they said, okay, let's look for forests that are at least 100 years old and at least 100 acres. And those forest owners, we're going to help them by putting a stronger conservation easement on their forest and no log easement, and they will get financial reward for doing that. And I applaud the 500-Year Forest Foundation. Those forests are not open to the public. They are privately owned. So that's an option for people in Virginia that own special private forest land. Yeah, somebody commented here, the Nature Conservancy is heavy into management. Yeah, we used to think of them as the ones that would ride in on the white horse and save the places, but these days they are more open to management. And in fact, in their program, they call it the Working Woodland Program, where they're helping people get carbon money for their forests. They actually encourage forest management. So it's interesting. Somebody mentioned the book, The Overstory by Richard Powers, a fictional book. And I would also suggest reading that. It's a fabulous book. And I'm very proud and pleased to say that he read my books as part of his research. He read many other books, but he read my books as part of his research for The Overstory. And then we became friends. And he is one of our county coordinators for the Old Growth Forest Network, and a supporter. So thank you everyone for your attention.
Do you have, there are a couple more questions. Do you have another minute?
Okay.
Okay, sorry. Somebody has asked how a dedicated forest should be protected or is protected. And would then that protection protect them from pipelines and fracking and other extractive uses like that? And what would be the ideal acreage for a protected forest?
Well, I'll start with the last question first. They always say the bigger the better in terms of biology, conservation biology. And that's true. The larger a forest is, the more species you're going to find there. But sometimes we can't be picky. That photo I showed you where I was sitting in the trees in the Maryland Park, that's only 14 acres. But it's a beautiful old forest with a trail and a parking area. So we would put that in the network if it became protected. And forests can be protected in many different ways. For instance, well, the strongest protection is wilderness areas, and we do have a few of those in there. Then national parks are strongly protected. Only a few states have strong protection on their state parks, but California is one of them. We have a number of California forests in the Old Growth Forest Network. Then there's a Forever Wild easement is another way to protect. As I mentioned, a memorandum of agreement with an organization or a land trust or something that doesn't have strong legal protection, but it shows us intention. And then also there's the protection just from this community of tree people, right? That if we say, no, this is the forest that's in our old growth forest in this county, we're all going to stand up and let nothing happen to that forest. Because in the end, really, it's up to all of us who love forests to stand up for them.
We have 2 more questions and we're about at our time limit, but we did start a few minutes late. Would you be up for 2 more?
Okay.
Then we'll cut it off. Okay. The next question is from somebody with a real practical issue. How do I determine the age of my wooded areas, tree girth or cores?
Well, it would not be through tree girth because you can have a 320-year-old tree I've seen that's narrower in girth than an 80-year-old tree that I've seen. Because the girth really depends so much on the conditions. So a few of the ways that, well, cores would tell you for sure. But I really don't love coring of trees because it is damaging to the trees. And that's controversial. Some people say it's not, others it will, but I haven't seen the science to prove it one way or the other. So I like to err on the side of caution. And if I'm trying to save a forest that I believe is very old, I will ask for cores to prove it because some people just need that data. But if you don't really have to have that data and you're just curious, I tell more by the crown structure. There are some indicators that I've learned to look for in the shape of the crown and also the texture of the bark. So it's, if you go to these old growth forests that are in the network and we tell you about how old the age of the trees are, you might be able to develop an eye for aging a forest that way. And forest people like me, we love to go in there and just guess. How old do you think this forest is?
Give you a call. Okay, last question. Now that we have a new federal administration about to take the helm, what would you suggest the first steps would be for protecting nature in these forests at a federal level?
Well, the federal government does not always can't control what the states do with their state forests, but the federal government does own a lot of federal lands. So the first thing that I would do is look at their management of the federal lands. And that would be, as we talked about earlier, the national forests. We should reduce the cutting in the national forests and set aside more of those areas as preserves. I think that would be the first step that I would take. And I would love to meet with some of the new folks. I just heard tonight that Vicki Christensen her name is up for the head of the Forest Service. And, you know, a woman has also been named for the head of the Department of the Interior. So I think these could be much more positive times for forests than we've been through recently.
Fantastic.